Let's get this thing started. So welcome to this live workshop where we are going to dig into ultrasonic sensors. We already did one where we learned all about how it works, how to connect it. So if you want a little review, the link to that video is posted below. So we are going to move on and control a servo using the ultrasonic sensor and our humble Arduino Uno. So this is the ye old trusty HCSR04, and you can see that it has some giant owl looking eyes. These are transducers. One is marked R and this one is marked T. So this is the transmitting one and this is the receiver. So in essence, what happens, and there he goes. I'll be back. Now, if you have watched these streams, you probably have witnessed a ton of components just like flying off. And they're like, peace out of this project, because they know that the more projects they're involved in, the more chances are that they ain't gonna make it out alive. That's the way we roll around here. We were talking about the T and the R for the transmitter and the receiver. And so what happens is from the Arduino, we are going to send a 5-volt signal to this trig pin right here, this second one, and it will receive it. And what it does is it causes this transmitting transducer to send out a pulse. As soon as this pulse goes out, it's a specific 8-pulse pattern. This receiver here, or the echo pin, I should say more accurately, goes high and it starts to count. All right, when is it coming back? It's going to bounce. It's counting, it's counting, it's counting. Then once it hits the receiver, the echo pin will go low. So in order to calculate distance, we kind of got everything we know. This goes out at the speed of sound. So we got speed and time. We know this time back and forth, and then all you have to do is divide the time in half. So that way you get distance to the object and not distance to and back from the object. So let's get this little guy wired up. I'm going to make him stand up like this. So I'm just going to pop him in here and crunch him. There we go. He snaps right in, and we can see the orientation of the different pins. And so the first one on the left is VCC. We are going to power this with the 5-volt pin of the Arduino. And I'm going to connect him like that and see if I can reach the 5-volt rail. Or it's not specifically a 5-volt rail, but it's the power rail of our breadboard. There we go. So for those of you that are new to breadboarding, you can see the VCC pin right here. And tracing these line of holes, you can use any one of these holes right here. It's tapping into this red master line right there, which we eventually will connect to the Arduino. Right here, this 4th pin is our ground. So I'm going to go ahead, and this is kind of the only size I have. And you can see I picked a hole a little bit closer just to kind of burn some of this length that I got going on. And he's going to go into the little ground there. Next to VCC is trigger pin. So we'll use green for that. And I'm going to go in here and let's put the trigger pin in 9. Blue for the echo pin, which is right next to the trigger pin. So let's see if I can get these two like making friends, right? It's like in school where they put you sitting next to someone you don't know. And you got to try and make friends with them. Could be fun, could be awkward. All right, so our little guy here, the ground popped off. See, we already got sassiness going on with this circuit. But this guy's fully hooked up. The only thing left is to hook up power and ground to the Arduino. But we'll get to that. Next, we got our servo. And for the servo, I am going to power him externally. You can certainly power one of these little guys from the Arduino, given that you're not going to add any loads to it. But if you're going to attach something to it, then it's best to power it externally. The brown is your ground. The red is your VCC. And this particular servo can take up to 6 volts. So y'all know me by now. Guess what volts we're going? Maximum voltage. And we also have our orange signal pin. So that one we know absolutely has to connect to the Arduino because the Arduino is going to tell it how to work. So for this, I'm going to pop him into 7. This is already being used for the 5-volt Arduino. So I'm going to jump onto this other side, and it's not really going to affect the ultrasonic sensor because he's kind of like hovering above it. So I'm going to go maybe right here, and purple is going to be my positive, and black, obviously my negative right there, although I frequently switch them around and then wonder why things are smoking, hence the burnt spots on my breadboard. This guy needs power. So we have him plugged in, but no power plugged in. So I love picking up these female power adapters, making it super easy to plug into the wall. And you can see here, I have cleverly popped in some jumper wires, and I'm just going to plug him in and match up the red and black with the blue. Maybe kind of weave him in here. It's all about weaving, people. All of your components have to share a common ground. So you see we have stuff plugged into the ground here and stuff plugged into this ground, but they're not talking to each other. So we all know what we have to do. Everyone's got to get along. I'm going to connect those two, make a little bridge so all the grounds are connected. This still needs power. So I'm going to jump a wire from our red rail here onto the 5-volt of the Arduino. And you can see right there, right next to the ground is the 5-volt, making sure I stick it into the correct pin. And then ground from here, I'm going to put into right next to this guy. If you guys have questions about the wiring or about how all this works, don't hesitate to post in the comments. And we also have a community, a private community, where if you are working on a project and you would like personalized help walking you through and helping you with your code, definitely check it out. A link for my community is below. You know what time it is? To the code. And this is the code I put together. Now, we wrote this in real time with our community members to move the servo according to distance. So of course, we're working with servos. The very first thing we're going to do is include that servo library to make it way more easier to use the servo. Way more easier. Yes, that's, we'll go with that. I always like to give specialized name to my pins, like unique names, I should say. You can certainly use and hard code the actual numbers, but if you guys are like me, you start a project and it just keeps getting bigger and bigger and bigger. And you have to move pins around. And now you have to go through all your code, finding where these pin numbers are and change them. So if you set them up as variables, you have one place where you change all your pin numbers and it updates for the rest of the sketch. So here I'm using a constant integer. And that means it's a number that's not going to change. And for our servo pin, if you remember, we hooked it up to pin number 7. And you can call your pin whatever you want. And then we have our trigger pin, and that was hooked up to number 9. And then our echo pin, which is hooked up to pin number 10. Next, we're going to have to make some variables. And variables are like storage containers to store some numbers for us. One is duration, the time. What is the time that it takes for the signal or the pulse to go back and forth? We need to grab that and store it for us. And we're using a float. Many of you guys see int all the time because this could end up being a decimal point. And int stands for integer, which is a whole number. So we got to use the right container for what we're going to store inside. Then I would like to get 2 different types of distances, the distance in centimeters and distance in inches, because depending on what you're doing, you might need both. You can also convert to distance in feet, in meters, of course, keeping in mind that this thing can only read up to 13 feet. Next, we have our servo. And so our servo needs its unique name. We have to create a servo object because you might have a lot of them. So if you're trying to control servo, it needs to know which one do you want to control. So I called this one my servo because it's mine. It can't get away as much as it wants to jump off the table. And so you start it with servo and then the name of your servo. So all that pre-setup stuff is complete. And we get into the setup. And the first thing I want to do is initialize my serial monitor so we can actually see the centimeters and inches that we're getting for troubleshooting purposes in case things look a little wonky. And then I set up my pin modes. So for the trigger pin, I want it to act as an output because we are going to be outputting 5 volts to that trigger pin to say, hey, send the pulse. And then the echo pin is going to act as an input because it's going to be receiving when that echo pin goes low. The Arduino needs to know that so that way it'll stop the timer. And then finally, we have our servo. We need to attach it to a pin. And here you can either put the number 7 or because I already defined it as servo pin, I put servo pin. So we've attached a pin to the object called my servo. We've got the setup complete. We're about to start measuring. So what is the first thing we want to do? Well, I know I said we're going to send a signal to the trigger pin, but there's like a little step before in that we want to make sure that we start with a clean signal because there is ultrasonic signals all around. And that's why that pulse is a very specific 8-pattern pulse. That's what the unit can detect is, oh wait, this is the signal that Rachel actually sent versus all the other stuff flying around. So we want the trigger pin to start clean. And so we're going to digital write that trigger pin low. And luckily, we don't have to do it for very long. So delay microseconds, we do it for only 2 microseconds. Super fast, faster than we all can blink. Then after that's done, now we can send the trigger signal. So now I'm going to take that same pin, the trigger pin, and now flip it to high. And the magic number that the ultrasonic sensor is expecting is 10 microseconds. So we're going to hold it high for 10 microseconds. And that's what initiates like, oh, Rachel for real wants us to send the signal. But she's not joking this time. So then after the 10 microseconds, we then write it low. So it's got a clean 10 microseconds. So now the pulse is going. It's traveling to wherever it's going to hit something. This function right here, the pulse in function, is super helpful. It cuts down on a lot of the math that we're going to have to do. So as soon as the ultrasonic burst goes out, remember that echo pin goes high and the timer starts. So this is the function that is going to work with that timer. So it's going to return a pulse duration in microseconds. Here, we're going to use the pulse in. It's going to measure that echo pin so long as it is high. Now we're going to take this time and we're going to convert from meters per second to inches per microsecond because here we are using the speed of sound. By standards, speed of sound is 343 meters per second. Well, remember, we're doing everything in microseconds, so we have to convert this to microseconds, plus I want to get centimeters and inches. So that equals 0.034 centimeters per microsecond. All right, we're getting close now. So now that we have this in centimeters per microsecond, we can now grab that distance in centimeters. So what we're going to do is take the duration, the time in microseconds that it took to go and come back, multiply it by the speed of sound in the centimeters per microsecond. And remember, this is going and coming back. So we're going to divide it by 2, so we just get the going, and that is the distance to the object. So now we have the distance in centimeters. All right, and then we can take that info and do stuff with it. And now I'm going to convert to inches because that might be a little bit easier for some of your guys' projects. To convert to inches, well, 1 inch equals 2.54 centimeters. The distance in inches, all we're doing is taking the distance in centimeters, which it literally just calculated, and divide it by 2.54. And that gives us the distance in inches. Now we can choose which version of the distance we want to use. So now, in order to make sure we have everything set up right, let's print this information to the serial monitor. So I go serial.print the word distance, followed by a space. Right next to that, we're going to print the distance in centimeters, which it calculated up here. It's just going to drop whatever it is up here down to here. Then we are going to print centimeters. So we know that that's the centimeters, followed by a separator bar, because right next to it, I want the distance in inches. So in essence, we have centimeters and inches, and they're going to scroll, or I guess they scroll up together so you can compare that the math is working correctly and also the sensor is working correctly. It got dropped. We'll see what happens. And then we also want it in inches. So then it's going to print the distance in inches, which it literally calculated here. It's just going to drop it in there with the word inches. So that way I know which one is which. let's make the servo do stuff with this distance. So if the distance in inches, so I decided to go with inches this time, is less than or equal to 6 inches, what do we want to do? We want to rotate the servo to 90 degrees. So I'm going to take my servo and we're going to write it to 90 degrees. The servo, perhaps it's a head, a prop head, and it could just be looking to the side. And as soon as somebody gets within a certain distance, it looks at them. So you can use this for hunts, you can use this for attractions and exhibits, or fun robotic interactive elements. Or else, because what if the person has not come within 6 inches? If the object is further than 6 inches, we need the servo to stay at 0 degrees. So he's gonna have his head to the side. Further than 6 inches, it's going to be at 0. And then as soon as it hits the 6 inches, this thing's gonna look at you. And it's angry about something. If distance is equal to or less than 6. Somebody caught it. There we go. So this has to be reversed. You guys are like on it. Here we go. And it compiled. And all I'm going to do is pop the serial monitor here. And if you watch the servo, here I come towards the 6 inches, an unsuspecting victim. Oh, and it turns 90 degrees. Now, look what happens to the numbers. Watch those numbers as I get to the blind spot. Look, they freak out. 2,000? I'm not at 2,000 centimeters. So you want to make sure you're working within the range. And so here I come at 6 and bam, that creepy skeleton looks at me. That is pretty cool. But what if we make the servo such that it starts at 0? And as the person walks closer to the ultrasonic sensor right here, the servo turns according to distance, meaning it'll start at 0 and get all the way up to 180 here, almost like one of those paintings that has the moving eyes. And so the eyes are like this. And as the person walks towards the painting, the eyes slowly turn to look at you, like one of those creepy eyes following you type of paintings. We all know that. So I say we go back and just modify the code a little bit and see if we can achieve that. Bye-bye, code. Famous last words, and it's like, oh, I needed that line. So all the code stays the same because all the way up until here, all we've done is grab the distance in centimeters and the distance in inches. All we have to do here, and I'm going to put a couple notes for us, is simply map the distance that we get. So let's do it in inches first. Since we've been in inches, we'll do it in inches. To a servo position in degrees. So you see that we're mapping two different things, distance to degrees. What I'm going to do is create a variable and call it servo position. And we're going to get this servo position by mapping from where? We want to map the distance in inches. And let's start it at remembering that 2 centimeter blind spot. So 1 inch, right? So from 1 inch to 12 inches. Isn't that ruler a foot? We'll call it 12 inches. And so 1 is going to correspond to 0 degrees. And 12 inches is going to correspond to 180 degrees. Sounds good to me. And let's put a semicolon. So now we have told the servo, like this is how we're going to map this, but we haven't told the servo to actually rotate to that position. So let's do that next. And so we're going to rotate the servo according to distance. All right, so let's go my servo and we're going to write it. And we're going to write it by the servo position that it just calculated up here. It's going to pop it here in real time. Oh, it's that distance. Oh, I put distance, capital I, capital N. Capitalization totally matters. Do it again. Type it way too fast. All right, it liked it that time. So here's our little box, and your victim is out of range, and it starts coming closer. Look at that. Now that flip is when you get out of range. Here, it starts to freak out. Now you can see that the turns are a little bit choppy. And the reason for that is because we are converting inches to 180 degrees. So if you are mapping a really big number to a really tiny number, you get more choppiness. Let's, instead of distance per inches or distance in inches, let's do centimeters. And we got that 2 centimeter blind spot. So I'm going to start at 2 and I'm going to go to 30 centimeters because I think that's the last thing on my ruler. And we're going to keep this the same. 2 will equal 0 and 30 will equal 8. So instead of going from 1 to 12, now we're going from 2 to 30. So it's not mapping such a tiny range to a big range. It's less tiny to a big range. So let's see if that works. Oh, it went through the first time. We're getting good, people. Hopefully we're going to get some smoother movements now that we're using smaller chunks. All right, it's more smooth now. So long as I don't get too close. So you can kind of do your creepy eyeballs. Hope you guys had a blast. Hope you learned something and maybe get, a couple ideas going for the weekend. I'd love to see what projects that you're working on. If you have any questions about the wiring or the code, I actually have this exact same tutorial on my website and link for it is below. So if you would like to just grab the code and play a little bit, kind of move things around, check out my community so you can show me your circuits. We can screen share and see where you're getting stuck. I had a blast and I will see you guys next time.